All right, today we're going to work on a new type of factoring. So far you have done GCF factoring and double bubble factoring. And today's lesson is another type of factoring. It is a double bubble, but it's special. It's called a difference of two squares. So that's our topic for today. These are what you're looking at right now. These are the homework answers from last night from the Do Now worksheet. The Do Now picture that you had on Google Classroom. It was a Do Now picture, and it had a picture of a little person with an umbrella with rain in the corner. So these are the answers to that. You'll notice here for number 2, I'm showing a little bit of my work. So this should have been your first step for number 2. Take out a GCF. All the numbers are divisible by 2. And then after you take out the GCF, you focus on this quadratic trinomial and do a double bubble with that. And then this is your final answer. Again, as long as you have the same bubbles, if they're switched left and right, it's the same thing, right? With number 3 from that homework worksheet, you take out a negative first. This will make doing your double bubble on the next step much easier. Again, after you take out that negative, you focus on that quadratic trinomial and do the double bubble with that, and this is your final answer over here. Right? Now, number 6, I've got this big ... because it's not finished. All right, and I want to walk you through, this is what we're learning today. I want to walk you through how to handle something that looks like number 6. Right? So grab your notebooks and copy down number 6 from your sheet yesterday. The original problem had said 4x squared minus 144. So the first thing we did was we took out a GCF of 4. So we divided by 4. That got us x squared minus 36. Now, here's my little thought bubble. X squared minus 36, why is it different than anything we've done before with quadratic trinomials? Well, it's not a quadratic trinomial, it's a quadratic binomial. It's missing that middle term, that x that's usually in the middle. So really, this is x squared plus 0x minus 36. Right? There is no middle term, and when there is no middle term, we put a 0x there. So now I can do my double bubble with this. It would be x and x, right? I think to myself, this term here is negative, so it's going to be different signs. One positive, one negative. And I think I need things that multiply to make 36, right? And there's lots of things that multiply to make 36. So just a few is 1 and 36, 3 and 12, 6 and 6. There's more than this, but I'm just giving a few. But the key thing is when I go to my double bubble, I need the outside loop and the inside loop to combine and make 0. So the only way that they're going to combine and make 0 is if they're opposites of each other. So like, for example, maybe 5x and negative 5x, that cancels to make 0. 10x and negative 10x, that cancels to make 0. 20x and negative 20x. 6x and negative 6x. But I need it to be the same number but opposite in order to cancel, right? So 1 and 36, if I try to put that in, that's not going to cancel. They're not opposites of each other. So the only thing that's opposites of each other is the 6 and 6. If I put in 6 and 6 and make one positive and one negative, I will get an outer and inner loop that makes 0. And this is special. We call this a difference of two squares, right? And so this would be, I'm going to bring that 4 down in front. This was the final answer for that homework question, right? So we are going to focus today on this thought bubble here, the difference of two squares, right? So grab your notebooks. You can start a new section title. Today's lesson is difference of two squares. If at any point you need to pause because I'm just going too fast, just pause and rewind, catch up. So in order to be a difference of two squares, the setup of your binomial needs to be in this form right here, a squared minus b squared, okay? And when you see that format, you're going to use basically a formula. And the formula is a plus b times a minus b, right? And the reason this works is because if I FOIL this out, a times a gets me a squared. My outer loop would be negative ab, and my inner loop would be positive ab. These are going to cancel and make 0, right? So they're gone. And then, I'm actually going to clear some space here. The last term times the last term, if I multiply those, I get negative b squared, right? So when I FOIL this all out, I get a squared minus b squared. Now here are some things you have to remember in order to do this formula. There's 3 important things. Number 1, it has to be subtraction. So it has to be a difference of 2 squares, right? It can't be a squared plus b squared. It has to be subtraction. And when I say it, I'm talking about this thing here. It must be subtraction in the middle. It has to be a binomial, so it can only be 1 term, 2 terms. And both terms have to be perfect squares, right? Now, your list of perfect squares is this, right? 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. That's a perfect square. And you could keep doing this. These are your perfect squares that you need to know. Right? So now we're going to go through some examples. So example 1 is x squared minus 25. I'm going to check for a GCF. There's no GCF. Then I'm going to always go through these 3 important things. Sorry. Right. I'm going to go through these 3 important things every time and make sure these things are true before I use that formula. Okay? So, number 1, right? Is it subtraction? Yes, it is. Is it a binomial? 2 terms? Yes, it is. Are both terms perfect squares? Yes, they are. Okay? So when I'm checking for perfect squares, I want to make sure that this invisible coefficient here is a perfect square. So 1 is a perfect square. I want to make sure this is a perfect square. And I want to make sure that this number is a multiple of 2. That's what we'll say if something is a perfect square. So for now, we're just going to start off with all x squareds. And so the answer will be yes for that. So if that happens, what I can do is I can say x and x, right? And then when you're looking at the 25, you're thinking, what's the square root of 25, right? What's the perfect square of 25? And that answer is 5. So it would be 5 and 5, 1 plus and 1 minus, right? Always 1 plus and 1 minus in a difference of 2 squares formula. That's what the a plus b and the a minus b is. 1 plus, 1 minus. It's the exact same numbers, but opposite. We call these conjugates, right? These are conjugates of each other. When it's exactly the same, where the only difference is you have 1 with a plus and 1 with a minus, right? And then that's your answer. I'm going to show this one a little bit of a different way, explain it a little bit differently. Okay, is there a GCF? No. I went out of order here. Sorry. Let's go down to number 2. Okay, so number 2, this is a perfect square. It has an invisible 1. 100 is a perfect square. It's subtraction. It's a binomial. So I can do my difference of 2 squares formula, right? So I'm going to set up x and x, plus and minus, and then think to myself, what's the square root of 100? That's 10. So 10 and 10. Example 3. Is there a GCF? No. Is it subtraction? Check. Is it a binomial? Check. Is everything a perfect square? Check. 4 is a perfect square, 25 is a perfect square, and x squared is a perfect square. Now I'm going to show this example a little bit differently. All right, just another option of how to think about this. You could do this and say, what number squared gets me 25? And you put the 5 in there. And I could say, what number squared gets me 4x squared? Well, it would be 2, right? 2 squared is 4. And x to the power of 2 is x squared, right? So now, this is your a value in the formula. This is your b value in the formula. So double bubble, we could say a plus b, so 2x plus the b value of 5, and then a minus the b value of 5. Notice they're conjugates of each other. Same exact double bubble, just one is plus and one is minus. Again, it doesn't matter what order you go in. Doing this is totally optional. You don't have to do that. So let me show you how you could do this problem without that highlighted step there. Looking at number 4, it's subtraction, it's a binomial. 9 is a perfect square, 144 is a perfect square. This x squared is a perfect square. So then, set up my double bubble. I think to myself, what's the square root of 9? The square root of 9 is 3. So it would be 3x and 3x. What's the square root of 144? Oops, I realized I just missed something. Rewind. I'm going to start over again. I'm starting over again because I just realized this problem has a GCF, right? Both of these numbers are divisible by 9. If any of you caught that before me, good job. So I'm going to rewind here. And there we go. So now I'm going to do the double bubble with this. I'm going to bring down my 9. Difference of two squares, x and x, plus and minus. What's the square root of 16? 4. So that's what goes there. Sorry about that, right? If I hadn't done that, you would have seen the GCF at the end, but we always want to avoid that. So we need to ask ourselves always, is there a GCF? All right, so you're going to try these problems, pause the screen. Always ask yourself, is there a GCF first? Okay, one of these problems is prime. Go ahead, pause, try them, and then come back. Okay, so for number 5, there's no GCF. I'm looking at all of these. These are perfect squares. Square root of 49 is 7. And I'm going to do 7x and 7x. That makes 49x squared. What's the square root of 36? 6. Make one plus and one of them minus. That's your answer. For number 6, x plus 3, x minus 3. Number 7 is the prime problem. And it's prime because there's no GCF. And 10 is not a perfect square. So you cannot do difference of two squares if you don't have perfect squares. Number 8, there is a GCF. Oh, I was wrong. There are 2 primes. Sorry, guys. I'm really off today. So number 8, there is a GCF. I'm going to divide everything by 2. It's an 81. And then this is difference of two squares. X plus 9 and x minus 9. The order of those bubbles does not matter. And number 9 is also prime. Sorry, I only told you there was one. Sorry about that. So there is no GCF. It's really tempting to do difference of two squares because you see 9 is a perfect square, 4 is a perfect square. But notice we don't have a quadratic, right? If that's not a perfect square, we can't do difference of two squares. right? If it was 9x squared minus 4, that would be a different story. Okay, these are a little bit more of challenge questions. So we're going to teach them and do them, but just know that these are definitely more challenging. These would be more bonus type questions, but I think it's great exposure for everyone to try them. If you're looking to accelerate, you would definitely want to know how to handle these. All right, so let's go through number 10. There's no GCF. So you're looking at for a difference of two squares. It's a binomial, it's subtraction. 16 is a perfect square, 81 is a perfect square, it's looking good. And then notice now we have x to the fourth. So with our x, all we're looking for is that it has to be a multiple of 2. The exponent has to be a multiple of 2. So, anything that's divisible by 2 is considered a perfect square. So we're good. And what we're going to do, right, here's another way of thinking about it. Like what multiplies to make 16x squared, which is exactly the same where we can have conjugates, it would be 4x squared and 4x squared and 4x squared. That makes 16x to the fourth, right? What multiplies to make 81? That's exactly the same number 2 times, 9 and 9, right? That's our square root there. So we would do 4x squared plus 9 and 4x squared minus 9, right? I hope you all followed with how we got that. Now here's the tricky part as well. This can go further. We can do a difference of two squares again because it's a quadratic, it's subtraction, it's a binomial, and everything in it is a perfect square. So we're going to bring this bubble here down, right? I can't do difference of two squares with him because he's addition, right? Addition, you're stuck. There's no such thing as sum of two squares. I'm going to take this guy and do a difference of two squares with him. So what two things multiply to make 4x squared? 2x and 2x. What things multiply to make 9, right? What's the square root of 9? 3 and 3. 1 plus and 1 minus. So that's your final answer. Number 11. Number 11, I have a binomial, it's subtraction, everything is a perfect square, right? This could be x squared and x squared. This could be 1 times 1. So x squared plus 1, x squared minus 1. This guy can keep going further. X plus 1, x minus 1. This guy I'm just going to bring down. So this is my final answer. All right, x to the 6 minus 36. X to the 6 could be x to the third times x to the third, right? Remember when it's multiplication, you add the exponents. So these two things multiply to make x to the 6. And 36 is 6 times 6, right? So x to the third plus 6, x to the third minus 6. Neither of these can go further because 3, an exponent of 3, right? This 3 here, those are not perfect squares. It has to be a multiple of 2 in order to be considered a perfect square. So you can't go any further with that. All right, number 13, there's no GCF. I look at this and say, is it a perfect square? Yes, it is. It could be 5x to the fourth times 5x to the fourth. 4 is a perfect square, 2 times 2. Right? Then I would want to ask myself, can I go further with this guy? Because he's set up as a binomial, that's subtraction. X to the fourth is a perfect square, but 5 is not a perfect square, 2 is not a perfect square. So I cannot go any further with that, and this is my final answer, right? So a little bit of a challenging lesson. Go back and rewatch things that you have to. If you need to ask questions, I'm going to be online tomorrow in the Google Meet at, we're going to aim for 10 o'clock, right? So 10 o'clock, we're going to aim to be there. So if you have questions, go there. Also, you can post questions in the class questions document, right? All these links are at the top of Google Classroom. All right. Let me know if you have any questions. Your homework, there's an image posted on Google Classroom. It's 12 questions practicing mostly difference of two squares. I did mix in a few other things. There's only one prime question on that assignment, and you're going to upload a picture of your homework. If you're not sure how to upload, there's going to be a video explaining you how to upload. Try to make sure the image is not blurry because I want to see what you understood from today and how you're doing with the material. Okay, thanks guys.